By the end of this Blender tutorial, you'll be able to make this super cool text effect, which loops seamlessly using Blender's geometry nodes. Let's get started. All right, let's select the cube, invert the selection with Control-I, X to delete, and now we're left with the cube. Let's go to Geometry Nodes tab up here, and we'll add a new geometry node. We're not going to need this cube, so we can just click this node here, the group input, and X to delete it. The first thing we want to do is get some text on the screen. So if we Shift A and bring in a string, it should be a string to curve. So if we bring the string to curve, there's a string input here. The blue circle represents string. Yeah, so we can punch in text here. So we can say, hello world, and look at this output here, and we'll just go tilde to the top. There's our text. Now you'll notice that it's actually not even filled in, right? It's just the outline. So there's a node to fill that. It's called the fill curve. We'll add that, and now we have our text looking pretty good. It's always kind of weird, like tumbling around like the top view. So I'm just going to rotate this so that on the front, we can kind of look around on the front. It's a lot easier to just tumble around and navigate that way. So move these nodes over, and we'll add a transform. Shift A, search for transform geometry, but we want to rotate, and in this case we want to rotate 90 degrees around the X-axis, this red axis here. All right, so we will do a 90-degree rotation, and now it's standing up like that. Now it's infinitely thin, so what we'll want to do is give it some extrusion. So before we rotate, or I guess it doesn't really matter which order, after we rotate in, we can extrude this entire mesh. And by default, it'll extrude it a ton, but we can control that offset, as so. So this is actually the first excellent opportunity for a group input. Select these, move them over. If we drag this diamond out and type in group input, now we have this what's called offset scale. So 0.5, we'll suggest the input to be 0.5. So that now exposes this parameter here on the geometry node itself, on the modifier rather, so that we can tweak it here in the modifier stack instead of having to come in and find the right spot in your whole geometry node graph. So now we can actually change this to be like, where's the name? Oh, double click the name up here. So extrude amount. Name it whatever you like, actually. Actually, a fun pun, called like textrude. This is just my own API. Well, unless I decide to put this on Gumroad for other people, but textrude, that's fun. All right, so now we've got this actual 3D text. What I kind of want though, I want this like centered, just like personal preference for this. It doesn't have to be, like you could easily just have the origin be on the very left, but I kind of just, I don't know, for some reason feeling OCD, like I want the origin right in the middle of the geometry. So I think there's an option, if I remember, let's see, left, center, there you go. All right, so now we've got the origin in the middle. This is kind of a boring font, so stand by. I'm actually going to throw in a different font here so that it's a little more interesting. And to do that, you can, here's the font setting right here. So if you click the folder button, you can go into your file system, you can pull in a new font that you like and give it some different style. So I'm going to do that and I'll be right back. So I changed this to one of my favorite fonts. It's kind of like Fortnite-ish, kind of comic-y, kind of fun. I've seen it around the web. It's a commercial-free font, but it's called Luckiest Guy. One of my favorite font websites is 1001fonts.com. You can go on there, you can find fonts for personal use, for free for commercial use, which is the type of fonts I have to use for doing YouTube content. Great website, you can find all kinds of fonts. So give it a shot. That's not an affiliated link or sponsor or anything. It's just personal favorite. Look at that, it's great. So now we need to actually start manipulating the vertices to make this move the way that we want it to. Right now, if you look in the spreadsheet, we can see that there are no vertices. The mesh component doesn't have any vertices. What we do see is 13 instances, and actually each of these instances maps to one of the letters. If you were to go into this string, oh, this reminds me actually, let's make this a group input as well. And instead of having default, let's clear that field, drag in a group input. Now we get the string, bring back that side panel, and we'll call it text. And I'm gonna make that the first thing, hello world. Boom, we've got 13 instances, 0 through 12. It's 0 base, which is why it's not actually 13. But if we were to start removing some of this text, now we've got 5 letters, we've got 5 instances, 0 through 4. So each instance maps to one letter. That's not super important to know right now, but it might be important in the future depending on what you're doing. Right now though, all we want to do is say realize instances, and now we get all the vertices. Okay, so we go from just 5 different instances to having access to all of this different geometry. And it's all of these vertices that we'll need to manipulate. All right, so let's come back. Let's give this a bit more text. Let's say, I liked hello world, or maybe like happy birthday. My birthday's not for a while, but happy birthday. So we want to animate this, and we want to animate it, which means we need to move things around. And to move things around, we'll ultimately be setting a position so that the geometry will be changed in some way. So we want to manipulate every vertex over some duration to make this animate. Now let's do some initial setup. Now what I'm about to show you will actually be really beneficial for all kinds of text animations that you do in the future, or even other animations, honestly. Before we do that, let's add this and Shift P and F2 to give it a name. We'll call it text geometry. Yeah, we're gonna fill in this big blank here. So we've got the geometry, the vertices. So to explain what we want to accomplish, we want to manipulate these vertices over a specific duration. Okay, so we need a duration and we want it to loop. At the end of that duration, the animation starts again. We want that duration to be variable so that the user or whoever is using this can specify it in geometrynodes modifier. So let's start there. We'll say that the start of the animation, its progress is 0, and at the end of the animation, its progress is 1. And we only ever want the animation to go from 0 to 1, 0% to 100%. Well, we have access to a scene time node, and this is probably pretty small on screen, so I'll zoom in a bit, which gives us seconds. So as the seconds plays back, right now we're seeing the frames, but as the animation plays back, the seconds increases, and this scene time will give us the amount of seconds that has passed. So that will always continually be going up. Basically, even though seconds might be 60 seconds, our animation will play over 4 seconds. So we want it every 4 seconds to go from 0 to 1 and then drop back down, and then go from 0 to 1 and drop back down, 0 to 1, drop back down. You get the idea. So this is 1 right here, and this number will keep growing. The seconds keeps growing, but we only ever go from 0 to 1. So we'll take that seconds input and we'll run it through a math node, and we'll say wrap. We want it to wrap. So this value coming in, we want it to go from 0 to say 4 seconds, right? Our animation will be 4 seconds long. But in this case, we want it to be input. So we'll take this, maybe we'll make the default 2. We'll say group input, N to bring up this panel, and we'll call this duration. So now it's a 2-second animation. So every 2 seconds, this value will drop back down to 0. But we want to map this from 0 to 1, remember. So if we punch in 4 seconds, then this will go from 0 to 4, 0 to 4, 0 to 4. We want it to be 0 to 1. So in that case, it's just another math node. We'll Shift D to bring this over. We'll take this value and divide it by the duration. So if this node outputs 2, and we divide 2 by the duration 4, that means we know we're at, well, 2 over 4 is 50%, right? 2 over 4 is 1 over 2, which is 0.5. So that's 50%. So this here, this setup, we'll shift P, F2, we'll call this like T0, which will go from 0 to 1. So this is our progress through the animation. The next thing we need to do in order to manipulate the vertices is we need to map the bounds of our text to be from 0 to 1. So that as we go from 0 to 1 in progress, the progress will map to an X offset through this text. And so right now, the bounds of this text comes way out here, which is minus, I don't know what this is, like 40 or 30, I guess. This is 10, 20, 30, minus 30 to over plus 30. So minus 30 to 30. But of course, those numbers will vary. We need to take some simple algorithm to map the full extent of this geometry from 0 to 1. Instead of minus 30 to positive 30, it'll be 0 to 1. To do that, let's take the bounding box. And the bounding box gives us a minimum output and a maximum output. And what that refers to is the point in your geometry where all values in the vector, remember a point has a x, y, z value. So that's a vector with 3 values, x, y, z. Where they are the least amount. The min output gives us the point where are the smallest. In this case, we have negative y, negative x from the origin, and z is the lowest. So that's our min point there. And then really the max is going to be just opposite that. So this is our max. We don't need to be concerned about the actual values. We just want to remap them to be 0 and 1. And there's a map range node, which will take an input. You can specify the from minimum and from maximum, and then remap it. Full disclosure, I'm not totally 100% using this node. There's some really great videos on YouTube that will explain this node and visualize it, which I haven't taken the time to do yet to like really level up my understanding. But for now, don't worry too much about it. We just want to remap the x, the minimum x and the maximum x to 0 and 1. So if we take this min and separate x, y, z, we can choose which component of the vector we want to work with. In this case, the x, the minimum x, and that will be our from minimum. So let's say this is minus 30, it's going to map it from minus 30 and shift D to duplicate that. The max goes in to split out the x as well, and that's our from max. So now this setup will take whatever this minimum x is and whatever this maximum x is and output the values 0 and 1, which is what we want because that also aligns with our progress. So as progress goes from 0 to 1, we can manipulate the vertices that are from 0 to 1 as well. So let's shift P and F2 this. Actually, I'm going to split it up. Don't shift P. Let's drag this out a little bit further here. We'll shift P this one and call it map min max to 0 and 1. So that's our remapping. Of course, the geometry is this geometry plugged in here. But what is the value that's getting remapped? It's the value coming in from this position, and it's x. Every point in this geometry coming through gets rejiggered so that its value is within this 0 and 1 x space. Okay, so we'll call this bounds mapping. So now we've got the min to max mapped 0 to 1. We've got the scene time, the seconds, 0 to 1. We've got our bounds mapped from 0 to 1. We are pretty much ready to start actually manipulating the vertices with some kind of effect. So to get this worm effect, oscillating text effect that you saw at the start of the video, the shape is like this. We want to manipulate the vertices such that when t is 0, the text on the left is just starting to move, is about here. And then when t is 1, at the end of the animation, all the text has moved through this shape and has settled back down, which means when halfway through the animation, the text in the middle, about here, should be at its highest and then settle back to nothing at the very end. And then we would loop back to the start. We can draw that graph using a Shift-A float curve. And this will manipulate values coming in and output values coming out depending on the shape in this graph. So to achieve that effect, we can add a control point here whose value is 1, and we can specify 0.5. Let me zoom in a bit so it's bigger on screen. We have this last control point here we can bring down to 0. So x is 0, or x is 1, right? If we bring this further over, you can see how it goes down to 0.8, 0.7. I think you can hold control to snap in increments as well. And its value is 0. But we also want that kind of worm effect. So if we add another control point here, add one there, I think that's like mirrored 125. And this should be 1.0 minus 125, which it is. We can confirm it by doing math in the field. 1 minus 0.125, oops, 0.125. So it's the same. I just want to make sure that these control points are essentially mirrored across the halfway mark. So if you manipulate one of these, which you might want to do, you can say like 0.2 and copy this value, 0.8, and hover over this and paste that value in. So now we've got this mirrored effect. We can actually widen this so we can see it better. So this is how we want the vertices to travel. And later on, we'll want to add some kind of amplitude scalar to affect how high or what amount this value actually represents. This is just 0 to 1. We may want it to offset a lot or a little, depending on some amplitude. So now let's just try plugging some values in to see what happens. Basically, we want to take our t. We want to say, where are we in respect to the progress of our animation? So what's the difference between t coming in and x? If x is 0 and t is 0, then we should be just starting out. If t is 0.5 here, so let's just plug that in and see what that does with the offset. The problem here, we're going to learn by doing, is that we've got this weird, it's affecting all three axes, because we've got a float value converting to a vector. I think the term is splatting, where it will put this value into all three axes. We don't want that. We want a vector of combine x, y, z to be this value to offset only the z value for now. So now you start to see only the z values being affected on those vertices. And the amplitude's pretty high, so we can throw that in right now. Again, we're gonna learn by doing. We'll just tweak this as we go. So this value is straight up plugging into z. We want to scale that somehow. So we can add a math node and take this value and multiply it by some value. So if we say a value of 1, I think what that means is that at its height right here, you can see that this is 1 right there. So this is an amplitude of 1. While we're here, let's just add a group input, and we'll call that, pressing N to bring in this panel, amplitude of 1. So now it's just a 1 to 1, but we can of course increase that so that it's 2. It comes way up to this 2, and we can decrease that. So it's maybe 0.25. Looks a little more subdued, right? 0.3. And you'll see it kind of jump because, well, there's two reasons it's jumping. We'll figure that out. One is the frames end at 250 and then it just snaps back to 0. It goes here and then snaps to 0, 250. So whenever you adjust the duration, depending on the frame rate of your project, in this case 24, I'm going to say 60. Whenever you adjust that duration, you want the frame rate of 60 times this duration. So 60 times 4 is 240, and then you want it minus 1, 239. And then it will loop. But it's not looping properly yet. And what we need to do is a tiny bit of math here and times by 2 and give that a play. And that should go all the way to the end and then keep looping properly. The reason for that is because when we take a map range, or this bounds mapping, which is 0 to 1, and subtract 0 to 1, we never actually hit 1. We never go through this full curve. At most, at x1, t1, it's 0. So you actually end up back here. the value becomes 0, so you end up back at the start of this curve. But if we times t by 2, now when x is 1 at the very end, and t is now 2, you have 2 minus 1, you get 1. You get the full traversal of these values in this float curve. And you get the proper shape from start to finish. So again, we can play that through, and there's our shape. So this is looking great. We can speed it up by saying a duration of 2. So now every 2 seconds. But of course, since we changed the duration, we need 60 times 2. I wonder if I can do 60 times 2 minus 1. 119. All right, so this is a completely seamless loop. It looks super cool. But there's something cool about this as well that's kind of hidden. We actually have 3 effects. We have this wave effect, but it also can be 3 different effects total if you simply change this input to be X. Now you get like this kind of like bumpy feeling worm effect across the X-axis. Or Y, you get this cool effect that goes from back to front. And it doesn't look as cool going in the positive Y, but if we, in this case, were to add a math node and multiply it by -1, now it goes to the front. And let's just hide. All right, so now there's these 3 different effects. There's across the X, there's the Y, there's the Z. That's -1, of course, now it's going down, now it's going up. What if we made it so that you could easily change in the geometry nodes modifier which effect it was? Well, you can, using a Shift-A menu switch. Now we want this to say a vector. Okay, and if we bring this in and add this to a group input, now we get this menu here, A and B. So now from this modifier, we can select which vector we want. Well, we want 3 vectors, which you can manipulate the options here by going to, again, if you don't have the sidebar, press N to pull it up, go to the node tab here, and now you can press plus to get however many options you want. Okay, A, B, item, that kind of thing. Well, we want a positive X option. We want a negative Y option, right? How we add it, or we multiply by -1 when we were testing the Y axis. And then we want a positive Z option. All right, so now if you go back to group, we'll name this axis. So now all we need to do is specify the vectors here. So positive X will be 1, negative Y will be -1 on the Y component, plus Z will be +1 on the Z component. Okay, so we can get rid of this, Command X to cut it. And the value coming out here is just one value. So when you take a float and you times it by a vector, that value, we'll say 2. Let me draw this, 2. 2 comes out of here. And then you times 2 by this vector, or this vector. When you times a float by a vector, it's just timesing that number with each component. So this vector will be 2, 0, 0. And 2 times this vector will be 0, -2, 0. And for Z, you guessed it, 0, 0, 2. So all we have to do now to get the right value, the right vector, and its value is just, and we'll need a vector math, and this value will plug into the top. And again, it will splat this value. So if it's 2, this vector will look like 2, well, just drag these across, will look like 2, 2, 2. Okay, for example. But because we have all these zeros on the axes we don't want affected, it'll just result in 0. And the one that we do want affected will be 2, 0, 0, 0, -2, 0, that kind of thing. Okay, so a little bit tricky to know like how floats and vectors interplay. There are some gotchas there, so it's worth knowing. But now, if we go and play back, we've got the positive X, so we can see that Interesting. No, it's actually on all three axes. So we need to do some debugging now. Oh, I see it. I see, my bad. We're adding. We don't want to add them because then we would get some weird vectors with populated values instead of zeros. We want to multiply. Okay, I was freaking out. That was a lot easier to fix. All right, so now we've got the z-axis, we've got the x-axis, and that's kind of slow. Let's give it some more spunk. Happy birthday. And we've got the y-axis, which doesn't look good in orthographic view, but if you had a camera and you had it rotated like that, you could also say like, you can say subscribe. There you go. I don't know which one my favorite is. What's your favorite? Let me know in the comments, because negative y is cool. I like the squishy, the shoulder bump kind of thing, and then the worm effect. So super cool. Anyway, hopefully that helped you guys learn some cool stuff about geometry nodes, and especially get some cool text effects. Totally subscribe if you want to see more videos. See you in the next one.